All right, this recording is going to cover the second half of the review worksheet, questions 26 to the end. I'm not sure how long it's going to be, but my guess is it could take a little while. So let's get rolling. Question 26, can a fifth degree polynomial have exactly 4 x-intercepts? Technically, we could ask that or answer that two different ways. If a fifth degree polynomial has 4 x-intercepts, it has 4 real zeros. Remember from the fundamental theorem of algebra, there are going to be 5 zeros. So if 4 are real, that leaves 1 that's imaginary. That can't happen because imaginaries come in pairs. So one answer could be no, right? We could say the answer is no. No, I don't want that. Let's go a little smaller. We could say no, imaginary roots come in pairs. Okay, so there's one answer. Well, if imaginary roots come in pairs. Right. Well, if we look at this as having 1, 2, 3, 4 x-intercepts. Exactly 4 x-intercepts. 1, 2, 3, 4. If my graph looked like this, touched, bounced off, and went through, it has 1, 2, 3, 4 x-intercepts. But it has 5 zeros because this one here counts as 2. Remember, if your factor is squared, it has a multiplicity of 2. So you could say yes if one 0 has a multiplicity. Sorry, writing into my other graph. You get the idea. I don't need to write it out. If it has a multiplicity of 2. So can a fifth degree polynomial have exactly 4 x-intercepts? Yes. If there's one with a double root or a multiplicity, or you could say no if you're considering this. If I change that, can a fifth degree polynomial pass through the x-axis exactly 4 times? Then the answer would definitely be no, because then you can't have a double root. All right. I think that explained it. If x equals -3 is a 0, what would be the factor? X plus 3. Remember, the 0 is what makes the factor 0. Simplify each expression. I'm just going to multiply like terms. So 7 times 3. When I multiply like bases, I add the exponents. B minus, that becomes 0. So b to the -3 times b to the +3 is b to the 0, which is just 1. No negative exponents. I have a negative exponent, so I can write that as 21 times 1 over a, which would be better written as 21 over a. When you multiply like bases, you add the exponents. Right. I can't really touch anything in here as far as like simplifying this way until I get rid of this. That's not totally true. Since these are the same, I technically can, but let's just get rid of that first to make things easier. I could reduce the 10 and the 5 first, so let's do that. 10 and 5 reduces down to 2 and 1. X to the 5th to the 6th is x to the 30th. 7 times 6 is 42. The 5 went away, so I have x to the 18th and y to the 36th. Leave the 2 alone. Subtract 30 minus 18 is 12. 42 minus 36 is 6. There's no negative exponents. We're done. Now I can't just make a statement and not say what I was talking about. Nope, I don't want that. So technically, since that 6 is the same on top and the bottom, I could have done this and written it as 1 exponent. And then now I could reduce it first. And 5 minus 3 is 2. 7 minus 1 is 7 minus 6 is 1. Raised to the 6th. Multiply 6 times 2, I get 12. 6 times 1, I get 6. So because these are the same, I could write it as a single fraction raised to a power, and then I could reduce these. Had that been a 5, this would not have been possible. Had that been anything other than a 6, what I just did would not have been possible. Okay, I had to show you that because I made this statement earlier. All right, this negative coefficient does not make this 1 over 4. A negative exponent is what makes it 1 over. This negative 4 I'm just going to leave alone. No, I'm going to get rid of that for a second. I want to show you another way of thinking about this. Think about this as a fraction. When I have a fraction, I can move terms up and down. And when I do that, I change the sign of the exponent. That negative 4 is not affected by the negative 3. This negative 3 does not apply to the negative 4. I'm going to leave the negative 4 alone. I'm going to move the m to the negative third power down to the bottom, and it becomes a positive. And I'm done. Or you could have used a definition of a negative exponent, and it becomes 1 over m to the third. Think of this as a fraction, top times top, bottom times bottom, and we get the same answer. Sometimes this technique, making it a fraction and moving terms up and down, makes it a little easier. Okay, anything raised to 0 power is 1. That whole entire term is being raised to 0 power, so my final answer is just 1. Had I had something like this, 3x to the 0 power, the 0 only applies to the x, and this would have been 3 times 1. But since the parentheses are there, the whole thing gets raised to 0 power, and so it's 1. Question 29. If the expression has a fractional exponent, write it using a radical and vice versa. So this becomes, and quit writing. This becomes 7. The power goes on top, the root goes on bottom. That becomes 4/3. This one here is in exponent form. The power is on top, the root's on the bottom. So this becomes the cube root. Didn't give myself enough room. This becomes the cube root of n squared. The squared can go here, or the squared can go outside. I'll put it here because it's easier to write. But that 2 could go outside also. I could put a parentheses here and make it squared. Either way is fine. Repeat the process. 2x, not 3x, 2x minus 7 raised to the power on top, root on the bottom. 19 raised to the 1. There's a 1 sitting here. 4th power. All right. Hopefully that was okay. Simplify. So let's just do what we just said. The root is on the bottom. The power is on top. Most of the time, I can't say every time, but most of the time, doing the root first is easier. So what is a cube root of a negative 64? Well, a negative 4 times a negative 4 times a negative 4 is a negative 64. So the answer, negative 4. You can take the cube root of a negative number. You cannot take the even root of a negative number. All right, 1 over, there's kind of can see the negative sign. This means 1 over the square root of 49, which is 1 over 7. When you have a power raised to a power, well, I could look inside. Do I know what the 5th root of 81 is? No, not off the top of my head. So I'm going to see if I can make this, see if it becomes easier by doing my power rules and multiplying the power times the power. The 5s are going to go away, and this becomes 81 to the 1/2. Well, now it's much easier. That's the square root of 81, which is 9. Root power, the square root of 25 cubed. Square root of 25 is 5, cubed 125. All right. Switching gears a little bit, solving. To solve a radical, we are going to raise both sides to the reciprocal power. Or if it's a square root, right, a 1/2 power, I'm going to raise it to the second power, or I'm going to simply square both sides. Square cancels the square root. That's why we did that. 4 squared is 16. Use my algebra skills. Add 2 to both sides. Divide by 5. X equals 18 over 5. Same logic. I have a radical on both sides this time. It's okay. The technique is to isolate one of the radicals and then square both sides. Well, in this case, they're both isolated, which is okay, because when I square both sides, the radicals simply go away. Again, use my algebra skills, subtract x from both sides, add 5 to both sides. We're smart. We can do that. We can do 2 steps in 1 step. X equals 8. Okay, this one's a little bit different. This one is in the form of x squared minus 2x equals a negative 1. Since it's, excuse me, had something in my throat for a second. Since it is the middle term is 1/2 of the first term's exponent, 2 compared to 1, 1 compared to 1/2, I could be looking at x to the 4th. Okay, all of these are in the same format. Nope. All of these are in the same format. The middle term exponent is 1/2 of the first term's exponent. So all of these are factorable. So I'm just going to do what I would do if I was going to factor this thing. I'm going to add 1 to both sides so that my equation is set equal to 0. And then I'm asking myself, what 2 things multiply together to give me x? And it's going to be this term here. So the square root of x times the square root of x is equal to x. Square root of x times square root of x equals x. Because remember, that's my first question. What 2 things multiplied to give me the first term? Normally it's just x times x, right? But notice that this and this is the same. That's why it works. So in this case, square root of x and square root of x, when I combine like terms, I will get square root of x's. So it's going to work. All right, what 2 things multiplied together to give me 1? Well, I have one option, 1 and 1. Do those happen to add together to give me 2? Yep, but I want a negative 2, so they're both negative. If this is positive, these have the same sign, and I add them together to get the middle number. A negative 1 plus a negative 1 gives me a negative 2. All right, so now using our solving techniques, the square root of x has to equal 1, which means if I square both sides, x has to be 1. Same over here, I get one answer, x equals 1. Okay. Isolate the radical, or isolate the term that's being squared. Divide both sides by 4. You cannot distribute this 4 because of this exponent out here. So this becomes 3x minus 5 raised to the 3/5 power equals 8. So I made the comment over here. Nope, I made the comment over here that I'm going to raise both sides to the reciprocal power. That's exactly what I'm going to do here. I'm going to raise this side to the 5/3. I'm going to raise this side to the 5/3. The 3 and the 5 cancel, and I just get 3x minus 5. Right? When you have a power to a power, you multiply the exponents. Well, if I multiplied 3/5 times 5/3, all these just go away. I don't get 0. I get 1, right? Because they are dividing out. These are all 1s. Okay. Cube root of 8 is 2. 2 times 2 times 2 times 2 is 32. Add 5, divide by 3, and x equals 37 divided by 3. If you want to grab a calculator and type that in, I don't care, but 37 over 3 is fine. What's my rule? Isolate the term that's being raised to the exponent, raise both sides to the reciprocal exponent to get rid of it, and then solve with what's inside. Okay, moving on to function and function notation. F plus g of x simply says take f of x and add it to g of x. Whoops. add it to g of x. Combine like terms, I get negative 2x plus 8. Question B, multiplication. Take f and multiply it by g. So f of x, 3x plus 2, multiplied by 6 minus 5x, negative, nope, sorry, not negative, 18x minus 15x squared plus 12x minus 10x. There's no x on that one, sorry, minus 12. All right, combine like terms, I get negative 15x squared plus 8x plus 12. Simple FOIL. All right, this means f of 8 minus g of 8. So f of 8, put 8 right there. I get 24 plus 2 is 26. G of 8, put 8 right there. I get 40. 6 minus 40, negative 34. Subtract. Oh, be careful. I need to be careful. It almost got me, but it didn't. I caught it. Whoops, wrong one. That one's okay. It's not letting me undo. Hopefully some of you saw my mistake. My almost mistake. So I have 26 minus, and the answer to g of 8 is a negative 34, right? 6 minus 40. So it's f of 8 minus a minus 34 becomes positive, and when we add those together, we get 60. Okay. Not multiplication. This means g with f plugged into or substituted into g. This is g of f, g combined with f, a composition function of g and f. But what it means is that right there. They give us a value of x. They give me a value of 2. So my first step is to work from the inside out. So f of 2, I put in 2 for f. 6 plus 2 is 8. And now I evaluate g of 8. Put 8 right here, and we already did that over here. It's a negative 34. Okay, same thing, just no number. I'm going to leave it right here. I know it's at the bottom of the screen, but that way I can see. We're going to put g into f. I'm going to take g and put it into the x in the f equation, just like I did here. I put the value I got from f of 2, which was 8, and I put it into the g function. The difference is I just don't have a value to plug in, so I have to plug in the entire function. So this becomes 3 times g, which is 6 minus 5x plus 2. 3 times g of x. I'm taking this expression and inserting it into the x. Why? Because this is a composition. This is f with g plugged into it. Okay, combining like terms, I get 18 minus 15x plus 2. I can slide down now. And I get 20 minus 15x. Okay, g raised to the negative first power means find the inverse. To find an inverse, I simply switch the x and the y. There's my y, there's my x, switch them. So I get x equals 6 minus 5y. Doing a little algebra solving, I get x minus 6 equals a negative 5y. Dividing by negative 5. And there's my inverse. Writing it in good notation, I get x minus 6 divided by negative 5 equals the inverse of g. Okay, we made it through that section. All right, prove or show. I cannot start with f, find the inverse, and see if it's g. Remember, in order to find an inverse, I need to do the composition function of f and g, and then g and F. If either one of those don't work, I can stop. However, if one works, I have to keep going and make sure the other one works. And when I say it works, I mean it equals X. I'm going to put G into F. So I get 2 times G. 2 times a half is 1, so I have 1x. 2 times 3 is 6. Which one's a minus? This was a minus. Minus 3, which does not equal x. I'm done. I don't even have to do this. That didn't work. It doesn't matter if this works. Same thing. Put F into G. So X becomes that big mess. So I get 2 cube roots of X minus 3 cubed divided by 8 plus 3. 2 cubed is 8. A cube cancels a cube root, and so I get X minus 3 divided by 8 plus 3. 8's cancel, and I get X minus 3 plus 3, which is X. All right, repeat the process. Sorry, I wrote way too big. Repeat the process. Just because it works in one doesn't mean it works in the other. If it doesn't work in one, I don't need to worry about the other. Take this mess, put it right there. So I have X cubed over 8 plus 3 minus 3. That goes right there, and then I have the minus 3. All right, plus 3 minus 3 goes away. Take the cube root. Cube root of X cubed is just X. Cube root of 8 is just 2. 2 times that, 2's cancel, and I get X over 1, which is just X. Doesn't equal X, not inverses. Both of these equaled X. These are inverses. This one is a yes. This one is a no. Okay, 34. Too far. 34. Remember, if there's nothing written down here, this is an implied base 10. This question is asking 10 raised to what power equals 100? The base, the exponent, this is what it needs to equal. 10 to what power is 100? That'd be 2. Same question. 4 raised to what power equals 64? Answer 3. Okay, this one I can't do in my head. 18 raised to what power is 126? I don't know. So I got to go to my other technique, which is to take the log of both sides. And why would I do that? Because if I take the log of a number raised to a power, that power can come in front. And the problem with this is my variable's in the exponent. So somehow I have to get the variable out of the exponent so that I can solve. And this is how we do it. Take the log of both sides, bring the exponent down in front. Divide both sides by the log of 18. That's just a number, right? Log 18, just a number. This is like 3x equals something. How do you solve? You divide both sides by whatever is right there. Grab a calculator, type in the log of 126, divided by the log of 18, and your final answer should be 1.67. Okay. I'm going to use the change of base formula. Change of base formula says take the log using any other new base you want of the expression divided by the log of the same base of the base. So the log of 69 divided by the log of 6. Log of the expression divided by the log of the base using any new base I want. If you used ln, we would get the exact same value. I would want to use one of these because these are the ones that is on our calculator. Grab a calculator, type in the log of 69 divided by the log of 6, and you should get 2.36. Okay. Going to go back to what we did up here. Switch forms. 3 raised to this power. So 3 to the second power equals 3x minus 1. Simply using exponents to solve logs. Switching forms. 10 to what power equals 100. 3 raised to the second power equals that mess. I could have done that here also, but I'd had to gone through the whole process of what we did over here. And change of base form is pretty nice for that. Okay, this is 9. Add 1, divide by 3, and I get 10 divided by 3. Okay. Oh, that's a plus 1. Sorry. That's an 8. I missed the plus. I wrote it as a minus. All right. Next one. I need to make question F look like question E. I need to take these 2 logarithms and somehow condense them into 1 logarithm so I can switch forms and solve. Remember your properties. If I have the log of one expression minus the log of another expression, the way I solve that, or the way I can condense that, is the log of the first divided by the second. And I'm right back to what we did right here. 10 to the negative first power equals x over x plus 3. There's a couple ways of doing this. I can go to a decimal and multiply by the denominator and all that kind of stuff. I'm going to think about it like this. Change this to 1 over 10, because 10 to the negative first power means 1 over 10. And I'm going to cross multiply. 10 times x equals 1 times x plus 3. Subtract 9x equals 3. Divide x equals 3 divided by 9, which is 1/3. You could have made this a 0.1, multiplied both sides by x plus 3, and you could have solved it that way. Either way is fine. Okay. Letter G. My goal, get that mess by itself so I can repeat what I just did up there. So think of this as 24x minus 3. My first step, add 3 to both sides. I'm going to skip steps because we're in Algebra 2, not Algebra 1. I'm going to divide by 24, and I get 0.75 raised to the x plus 2 power. And fix my writing. All right, do what I just did up above. Take the log. Oh, you do ln just for the fun of it. When I take the ln of this, I can bring this in front. So I'm going to do 2 steps in 1. Again, because we can. I'll put parentheses just to distinguish this decimal point, and so on. This is a number, so I'll divide both sides. So ln of 17 over 24 divided by the ln of 0.75 equals x plus 2. Work all this mess out. Subtract 2. Final answer is 0.38. Type this in, divided by this. When you're done, subtract 2, and you should get 0.38. No, you don't. I looked at the wrong number on my answer key. Let me look at the right number on the answer key. Oh, I didn't do it. I'm going to hit pause and do it real quick. All right, I got, to reset my pen, I get x equals negative 0.8. Okay, now it's just a repeat of some things we've already done. Take the log of both sides, bring the x in front, divide by ln of 8. Grab a calculator, type that in if you want, and you get 0.86. That one should have been just like super easy. Okay. I'm going to use, this is just a number, right? Log of 17 base 5, that's just a number. 5 raised to what power? 17. I don't know, 1 point something. So I'm just going to type this into the calculator like we did up here. Just use my change of base formula. Do we see how those are the same? So I'm going to use ln of 17, or no, I'll use log, common log. Log of 17 divided by the log of 5. And when I do that, I get 1.7, etc. And now I'm back to a linear equation. Subtract 1, divide. And this is 0.7, etc. And it actually comes out to be 0.38. It's actually 0.76, etc. I just didn't write it all down. Okay, I think that's the end of page 1. Page 2. Question 35. What is the domain and range of a logarithm? Remember my log. Base 3 looks like this. When x is 0, y is 1. When x is 1, y is 0. When x is 3, y is 1, right? If I put a 3 right there, and I get my logarithm graph. Vertical asymptote sitting right here. What is the domain of that? Domain x is greater than 0. What is the range of that? Well, it's all real numbers. This goes forever that way. It goes forever up. There's my range. Okay. Formulas. You probably want this formula in your notes. Amount equals principal times 1 plus r or minus raised to the t power. What is p? The initial population. What is r? My growth or decay rate is as a decimal, and t is time. So the amount after some point in time is equal to 4,000 people. It is growing, so it's 1 plus 0.035 raised to the t power. Now, how long will it take for the population to reach 10,000 people? Plug in 10,000 and solve. Divide both sides by 4,000, I get 2.5. I'm going to get rid of that plus sign. Take the log of both sides. I'm lazy. That's ln's one less letter than log. Divide by 1.035, and t comes out to be 26.6 years. So my thought then, logically, would be, well then, if it takes 26.6 years to get to 10,000, then it must take twice as long to get to 20,000. Not true, because it's growing at a percentage rate. It's growing exponentially. So I can't just assume that because it's not true, and I need to solve. So I do the exact same thing I just got done doing. Nope, that's not a 4. That's a 4,000. And solve. Put 20,000 equal to my equation. Divide by 4,000. Take the log of both sides. Bring the t in front. Divide by ln of 1.035. Grab a calculator, type it in. T comes out to be 46.78. Double would be something like 52 years, 53 years. So it's not double. It takes less than twice as long. Okay, 37. Half-life. You should write this formula in your notes. Amount equals principal times 1 half raised to the t divided by h power. P is my initial amount. H is the half-life. So in this case, there are 7,000 to start with. T is just t, and my half-life is 150. How long before the population is less than 100. Just for the sake of ease, I'm going to write as equal 100, and we'll talk about what makes it less than in a second. And I'm right back to what we just got done doing. Same exact thought process. I have a variable in the exponent, so I want to get the exponent by the exponential part by itself. I'll divide both sides by 7,000, and I get 1. What just happened? There's an equal sign there. So I get 1 over 70, right? 7,000. Oh, there's less than 1,000. I read that wrong. So there's 1/7 equals 1/2 raised to the t over 150 power. Take the log of both sides. You can see where we're going with this. So ln of 1/7 divided by the ln of 1/2 equals t divided by 150. Hopefully you can do the ln of both sides and the simplifying like we did right here, right? Hopefully we can go from here to here pretty easily at this point in time. The natural log of this divided by the natural log of that equals that. Multiply both sides by 150. Whoops. Multiply both sides by 150. Grab a calculator, type that mess in, and you should get 421 days. 0.1. So if we think about what's happening, half-life, this thing's coming down like this. So if this is 1,000 and it happens at 421, etc. days, then anything greater than that is when the population will be less than 1,000. You could say it drops below at for the first time after 421 days. Okay, so t needs to be greater than or equal to 421.1, etc. Sorry, not equal to, because it says less than. Okay. Definitely have those in your notes. Maybe the compound interest formula also. It's not on here. Compound interest formula. Amount equals principal times 1 plus r over n raised to the nt power. P is principal, the initial amount. R is my annual rate as a decimal. N is the number of times compounded in a year. T is time in years. Principal, interest rate, number of times compounded, number of years. You should put that in your notes also. Right? Question 38. Make a little table of values. Let me use my typical table of values. 1x is 0, now -2, -1, 0, 1, 2. 1x is a -2. A negative flips this fraction, and I get 2 times a -4, -8. Plug in a -1, flips the fraction, I get 2. Oh, sorry, I just did that. This one's a -8. Put in a -2. Negative sign flips the fraction. 2 makes it a 4. 4 times 4 is 16. One more time. Negative sign flips a fraction. The 2 becomes squared, which gives me 4. 4 times a -4, -16. Plug in a -1. -1 flips a fraction to the first power. 2 times 2 times a -4 is a -8. Anything to 0 power is 1, which gives me a -4. Half of a -4 is a -2. And you should see the pattern as we're cruising down. I don't even need to calculate anymore. If it was 3, it'd be a half, and so on. Lots of points. -2, 16 off my graph. -1, -8. -1, -8 right there. 0, -4. 0, -4. 1, -2. 2, -1. 3, -1/2, 4, -1/4, and it never hits the x-axis. Cruising up, flattening out. Don't cross the x-axis. Sorry, laughing at myself. All right. Equation of asymptotes. Y equals 0. The x-axis, y equals 0, is my horizontal asymptotes. Exponential graphs have horizontal asymptotes. Logarithm graphs have vertical asymptotes. Domain. Domain. Eventually going to hit all real numbers. Range. Y is less than, not equal to, 0. Y equals 0 is my asymptote. Y is less than 0 is my range. Domain, all real numbers. Remember, these go together in a exponential function, the range and the asymptote. In a logarithm function, the domain and the asymptote go together because they're x values. Okay. I'm going to switch forms. 3 raised to the y power equals x. I'm going to plug in values for y this time because y is now in the exponent, not x. So I'm doing this one a little different than we did this over here. This one I just made a table and plugged in points. This one I'm going to do a little different. So if y is a -2 in this equation, x is 1/9 because it means 1 over, right? Means 1 over 3 squared. Negative first means 1 over 3 to the first. Anything 0 power is 1. 3 to the first power is 3, 9, 27, etc. This multiplies my y values by -2. So all these switch signs. 0 can't switch signs. And these we're going to add 2 to the x's. But I'm going to do that by simply shifting my vertical asymptote right 2. I'm going to plot these points from this shifted answer. But you could also make that 2 and 1/9, 2 and 1/3, and then just plot points. That's totally fine. So I'm going to go by starting right here, over 1/9 up 2. So notice I am at 2 and 1/9 and up 2. Over 1/3 and up 1. Over 1 and up 0. Over 3, 1, 2, 3, and down 1. Over 9 and down 2. And my graph comes down along the asymptote, turns, and hits these points. I missed a couple, but you get the idea. All right, sorry about that. Someone, you don't know that someone just popped in. I had to hit pause. All right, let's keep going. I'm going to do the exact same thing here. 1/2 to the y power equals x. Not looking at that, not looking at that. Make a table, plug in values for y. Negative exponent flips my fraction. We've said that several times already in this video. So 1/2 becomes a 2. 2 squared becomes 4. Negative 1/2 to the negative, 1/2 to the negative first flips my fraction. It becomes a 2. Anything to 0 power is 1. 1/2 to the 1 is 1/2. 1/2 squared is 1/4, and so on. This negative x makes all of these negative, and I'm going to simply shift my x-axis down. If you like this better, make that a -3, a -2, a -1, a 0, a 1, and then just plot those points. Whatever works for you. Okay. All right, so I'll just do what I just did since I already plotted the points. -4, -3, -4, -3. And I'm not graphing it from the shifted. I'm just plotting points because I took care of all my transformations in the table. I'm just plotting points. Had I shifted it down 1, I'd be plotting these points and not those points. Okay, -2, -2, -2, -2. Where am I at? -1, -1. That doesn't look right. Maybe. 1x is -1/2 and 0. -1/4 and 1. All right, never mind. That looks good. So my graph cruises along here, turns, does not cross the y-axis. Logarithms have vertical asymptotes. My asymptote here, x equals 0. My domain, x is less than 0. It's on the left-hand side of the y-axis. My range, all real numbers. That's what I forgot over here when someone popped in. Domain, range, asymptote. Asymptote, x equals 2. The domain and the asymptote go together. In this graph, my values are to the right, so x's are all greater than 2, but my range is still all real numbers. These y values go forever that way and that way. Okay, sorry about that. This one here, make a little table. I'm not going to, well, we can do that if we want. Yeah, I'm not going to look at the negative sign, just 4 to the x, okay? When x is, no. There's two ways of doing this. We can do our transformations, or we can just plug in points and plot them. I don't know which way is easier. They're both about the same. Since I'm having negative, it's really easy. I'm just going to plug them in. -2 plugged in makes that a -2, which makes it a positive. So it becomes 4 squared, which is 16, minus 2, which is 14. Plug in a -1. 4 to the negative first is 4, minus 2 is 2. 4 to the 0 is 1, minus 2. 4 to the negative first is 1/4, and here's where it gets messy. Minus 2. 1/4 minus 2 would be a -1 3/4. Plug in 2, I get -1/16, and I get -2 15/16, and it just becomes a mess. Have a vertical asymptote, sorry, horizontal asymptote. Plotting my points, -2, 14, off my graph, -1, 2, 0, -1, 1, and -1 3/4, 2, -1 5/16, and so on. Okay, for those who are, anyways, let me finish graphing. So my graph comes down pretty steep and flattens out pretty quickly. Domain, all real numbers. Range, asymptote. Sometimes asymptote's easier. Asymptote is -2. Y equals -2. That thing right out there. It's my y value. Range, all my y values are above that, so it's greater than. Okay. That is not how we did it in class. So I'm just going to, for those of you who did it differently, here's what we did in class. We ignored the negative sign, right? And I just went y equals 4 to the x. Negative exponent makes that 1/16, makes that 1/4, makes that 1, makes that 4, makes that 16. The negative sign makes that negative, makes that negative, makes that negative, makes that positive, makes that positive. That doesn't make sense. Okay, there's no -0. Then we shifted our graph down 2 and plotted these points from our shifted graph. So I go over 2, up a 16th, over 2, up a 16th, over 1, up a quarter, over 0, up 1, left 1, up 4, left 2, up 16, which puts me up at 14. Whatever technique you like, it works. For the logarithms, I really think the transformations done in the table works better than trying to plot a whole bunch of points. Over here, since my exponent is pretty simple, I could just make a table of values. Whatever works. All right. Yeah, this is getting long. All right. I have 10 minutes for my preps over. Hopefully I get done. Give the equational function as a vertical asymptote. Exponential or log? Which ones have vertical asymptotes? logarithms. So I know it's going to be y equals log. All right. Asymptote at x equals 4. So I know that inside my graph or inside my function has to have an x minus 4. So my graph is shifted to the right 4. Range of all real numbers. Well, all logarithms have a range of all real numbers, but I want my graph as x goes to positive infinity, y needs to go to negative infinity. My graph needs to come, do we see our logarithm graph? It either looks like this, or it looks like this, or it looks like this. Got the idea? So I need my graph to have a vertical asymptote at 4 and come down, and as x goes to infinity, it needs to go to negative infinity. Normally my logarithm goes like this, so I need to flip my graph upside down. You could put a -2, -3, negative whatever you want, but all you need is a negative sign. Okay. If you don't have these from the paper you got for your chapter 8 test, I would definitely copy these down in your notes. X-intercept, value of y that makes the top 0. Well, can't really see it. I'm going to factor it. X-intercepts are points, 3, 0, and -1, 0. Y-intercept, put in 0. Putting in 0 for x makes that 0, 0, and -3. Putting in 0 for x makes the denominator 0. I get a -3 divided by 0. Not possible. Y-intercept does not exist. Vertical asymptotes. Values for x that make the bottom 0. Let's factor. When I factor out an x, I get x squared minus 25. We've done that so many times that this is super easy factoring. I get x plus 5, x minus 5. What makes the bottom 0? X equals 0, x equals 5, x equals -5. Notice these are equations. These are data points, or sorry, xy coordinates, not data points. They're xy coordinates. Don't put x equals 3 up here. That says my x-intercept is a line, a vertical line at x equals 3. Not true. It is a point. It's an xy coordinate. Use good notation. Okay, horizontal asymptotes. It's going to be a y equals, looking at your notes, if the degree of the top is smaller than the degree of the bottom, my horizontal asymptote is y equals 0. Poles. When there's a factor on top and bottom that are the same, there's not. Don't leave it blank. If you leave it blank, I assume you don't know how to answer the question. Right? Holes? None. Okay, let's graph this thing. Plotting all my points or all my key information. 3, 0, -1, 0, x equals 0. Do you see the difference? One is data point, or keep using the word data points. One is an xy coordinate. What are we at? 1, 2, 3, 4, 5. And one is a vertical line. Y equals 0 is my horizontal asymptote. Okay, we have 3 vertical asymptotes. Okay, we have 1, 2, 3, 4 different graphs. Don't make it too hard. Don't do it all at one time. We're going to do it one graph at a time, starting over here. If I go to positive infinity, if all of these were positive, my graph would be positive. So I have to be above my horizontal asymptote. Not down here. That would mean everything's negative over here. And if I put in a bunch of big values, this will be positive, this will be positive, this, you got the idea. Okay, okay, let's use some more properties. If my graph goes to positive infinity on this side of the vertical asymptote, it comes from negative infinity on this side. It has to pass through this point, has to approach that asymptote. It comes like this, passes through there, and goes down. Same logic. Over here, if it's going up, it's going to come from the bottom. It has to pass through this point, and it has to approach that asymptote. Ooh, that was horrible. Okay. Okay, now this one's a little trickier. If it goes from the top, then it has to come from the bottom. But let's just double check. If I put in like a -10, this is negative, this is negative, top's positive. If I put in like a negative 10, this is negative, this is negative, this is negative, this is negative. So my graph is going to be in the negative region over here, which does make sense to what I just said. If it goes up here, it goes down over here. Okay? All right. I don't think I'm going to get done. Let me erase this. I got 5 minutes. Can we do one problem in 5 minutes? All right. So same logic. I'm going to factor this thing. 2x and x. Factors of 12. 1 and 12. 2 and 6. 3 and 4. Whatever I put here gets multiplied by 2. Whatever I put here gets multiplied by 1. So I'm going to put a 4 here. I'm going to put a 3 here. And I get 8 minus 3, which is 5. I need a negative 5, so my 8 needs to be negative, and my 3 needs to be positive. This guy here becomes x minus 4, x plus 2, x-intercepts, etc. All right. This seems a little disjointed. That's because it's been about 5 hours break in between my last talking and now. So I will try to pick back up, and you may not notice it's been 5 hours, but it's been 5 hours, no more than 5 hours for me. All right, so let's see if we can finish this thing off. So x-intercepts is kind of looks like where I ended. Not sure, but that's kind of what it looks like. X-intercepts, what makes the top 0? All right, let's try that again. I was talking to no microphone. So the reason there was a big pause there is there was a large break. I didn't get it done during my prep, didn't get it done during school, and now it's late at night. So I'm trying to finish this up real quick. What it looks like, where it looks like was at is x-intercepts. So what makes the top 0 would be negative 1.5. Right? Negative 1.5 times 2 is a negative 3, plus 3 is 0. What makes this 0 is a positive 4. Sorry, I just caught something. Again, it's been too long in between. This one's not correct because that and that goes away. So my only x-intercept is a negative 1.5. I have a y-intercept. Put in 0, I get negative 12 over negative 8. Or if I put in 0 here, I get a negative or a positive. Put in 0 here, I get positive 3 over 2. Either way, negative 12 over negative 8, 4 goes into both, ends up with 3 over 2. 3 divided by 2 is also 1.5. So I have an x-intercept at negative 1.50, a y-intercept at 0, 1.5. What's next? Vertical asymptote. Only vertical asymptote, because this went away, is at negative 2. Horizontal asymptote. Horizontal asymptote. The degree of the top is a 2. The degree of the bottom is a 2. My ratio of leading coefficients is 2 to 1 because my degrees on top and bottom are the same. I could go over here and see my degree is 1, my degree is 1, and the ratio of the leading coefficients is still 2. Either in the original form or in the simplified form, either one gives me my horizontal asymptote. Holes, in this case we do have a hole. Value for x, that makes a canceled factor 0. X equals 4. Plug in 4 into the simplified version. 2 times 4 is 8, plus 3 is 11. Plug in 4 down here. 4 plus 2 is 6. The whole occurs at 4, comma, 11, 6, 1, 5, 6, either way. And sketch graph. I'm going to get rid of some of this stuff so I have a little bit more room over here. Horizontal asymptote at 2. Vertical asymptote at negative 2. x-intercept at negative 1.5, y-intercept at a positive 1.5, and the whole is at 4 and 11.6. 11.6 is just less than 2. 12.6 would be 2, so it's right up here next to the asymptote. Okay, this one's actually fairly easy to graph. I have to hit these 3 points and approach this asymptote and that asymptote. Well, that's pretty easy to see. It goes through there, it goes through there, so-called goes through there, and we got it. This side over here, if it's going to negative infinity on this side, it comes from up here, flattens out along the asymptote. And I can see that if I put in a negative number like a negative 20, this is going to be negative, this is going to be negative, a negative divided by a negative is a positive, it comes from the top. It can't come from the bottom because then it'd have to pass through the x-axis, and there are no x-intercepts over here. For a variety of reasons, it has to be up here. And for the reasons it has to pass through those points, this one has to be down there. Okay. Solve. To solve a rational function, we are going to multiply by the common denominator. Since this is one fraction, we could cross multiply, but I'm just going to keep the same pattern so that we are going to always do the same thing. Cross multiplying definitely works in this case, but not in this case because it's not one fraction. Sorry, I was trying to talk and write at the same time. Didn't work. So my common denominator is a 6 and an x minus 4. When I multiply the right-hand side by x minus 4 and 6, the x minus 4's go away, and I get 6 times 2, which is 12, which is what you would get when you cross multiply. The 6's go away on this side, and I get x times x minus 4, again, which is what you'd get when you cross multiply. Subtract 12 because it's a quadratic. I want to set it equal to 0. Factors of 12 that subtract. Why am I subtracting? Because that's a negative. Factors of 12 that subtract to give me 4 would be 6 minus 2. But I want a negative 4, so the larger number or the larger product has to match the sign I want. I want a negative, so the 6 must be negative. Solve. X could be 6. X could be negative 2. Check for extraneous solutions. Take the 6 and see if it works. Yep, doesn't make that 0. Take the negative 2, plug that in. Yep, it doesn't make that 0. They both work. Okay, over here, common denominator. Let me get this thing out of here. Excuse me. Why is it not dragging? All right, I'll just minimize it. All right, so we're going to multiply. We're going to factor this. It'd be amazing, not amazing, I guess. It'd be really nice if the factors of this were also the factors of the other denominators, and it does. Factors of 3 that add to 4 are 3 and 1. They both need to be negative so that I get a negative 4. Since these are the same, my common denominator is going to be that x minus 3, x minus 1. So we're multiplying both sides by x minus 3. And x minus 1. X minus 1 cancels, and I get 2x times x minus 3. X minus 3 cancels, and I get 1 times what's left, which is x minus 1. All of this cancels with all of this, and I get 2 left. No more fractions. Life is good. I get 2x squared when I distribute that thing, minus 6x plus 1x minus 1 equals 2. I'm going to do that in one step. I'm going to go ahead and subtract the 2. No, I won't. I have a lot of simplifying to do. Equals 2. All right. I'm going to keep the x squared on this side because it's already positive. Combine my like terms. Bring the 2 across. Set it equals 0. Take 30 seconds. Let's see if this thing will factor. Factors of 3 that give me factors of 3. Whatever I put here gets multiplied by the 2. Whatever I put here gets multiplied by the x. So I'm going to put a 3 here and a 1 here and ask myself the question, is 6 minus 1 5? Answer is yes. 6 minus 1 is 5. The larger product needs to match the sign I want. So that's a negative, that's a positive. What makes this 0? X equals -1/2. What makes this 0? X equals 3. Check, see if 3 works. Nope, 3 does not work. Makes this denominator 0. 1/2 works here, and since these are the same as those, -1/2 works. Okay, 47. Factor, 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 factor. If you start canceling this, yeah, we definitely know better than that. We have talked about that a bunch. Do not simplify that way. You can't simplify this from top to bottom when there is addition and subtraction in the problem. You have to factor this thing. All right, top factors into x. And x, factors of 4 that subtract to give me 3 are 4 and 1. I want a -3, so the 4 is negative on the bottom. Factors of 18 that subtract to give me 3 would be 6 and 3. Again, I want a negative, so the larger number is negative. These here are already factored as far as we can go. It's not division, so I just simply leave them alone. Anything on top can cancel with anything on the bottom. This goes away, and my only factors that are left are x minus 4 and x plus 3. Okay, over here on top I get 2x, what was that? 2x, sorry, I just can see I'm going to run out of room, so I got to go smaller or further over, a little bit of both. So I have 2x and x. Factors of 3 are 1 and 3. Whatever I put here gets multiplied by the 2. I need a 7. If I put a 3 here and a 1 here, I get 6 plus 1 is 7. Why am I adding? Because that's a positive. Why did I subtract over here? Because those were negatives. The last term tells me whether we're adding or subtracting. They're both positive because that's a positive. Difference of perfect squares. At this time in our mathematical career, at this time in the school year, we have to see difference of perfect squares. X squared minus 16 is x minus 4 times x plus 4. Division means I multiply by the reciprocal. We're going to put the factors of the bottom up on top. So how do I get 2x squared? 2x. 2x. And x. Factors of 12. 4 and 3, 2 and 6, etc. I'm just going to jump right to the chase. 4 and 3. 2 times 4 is 8. Minus 3 is 5. Why am I subtracting here when I add it over here? Because that's a negative, which means these signs have to be different. And when I put together an 8x and a 3x, when the signs are different, let's just say this is a positive and this is a negative, we are going to subtract. If this was a negative, why is my pen not working? And this is a positive, we are still going to subtract. When the signs are, sorry, my pen decided to quit working there. I was on a roll too. When my signs are different, if this is a positive and this is a negative, I subtract those two numbers. If this is a negative and this is a positive, I still subtract those two numbers. Okay, that was just a little bit of factoring reminders. Okay, this is a negative 12, so these two have to have different signs. I want a negative 5. My larger product has to match the sign I want. Negative 8 plus 3 does give me negative 5. All right, factors of 4. 2x and x, or it could be 4x and 1. I don't know yet. I'm going to try 2x and 2x. Okay? Factors of 3 are 3 and 1. Either this is going to work or it's not, because that's my only options. So 2 times 3 is 6, plus 2, does it give me 8? Had that not worked, I'd have gone to 4 and 1 and tried the 3 and 1 again, but in that case, I'd have had two different places I could have put it. If I switch the 3 and the 1 in this situation, doesn't matter because I have a 2x in both positions. All right, I want a positive, so both of them are positive. Anything on top can cancel with anything on the bottom. 2x plus 3, 2x plus 3, 2x plus 1, 2x plus 1, x minus 4, x minus 4, x plus 3 over x plus 4. And we're done. 49. Again, I'm going to factor everything. This factors into x and x. I have a negative 6, so I'm going to subtract my factors to give me 1. How about 3 and 2? Positive 1, so I need a positive 3, a negative 2. Factors of this are x and x. Factors of 6 that add to 5. Well, it's the same factors, 2 and 3 and 3. What's my common denominator? My common denominator has to contain all of the factors of each denominator. So my common denominator has to have an x plus 3 and an x minus 2. It also has to have an x plus 2. And it has to have an x plus 3. It already does, so I don't need it twice. So my common denominator is x plus 3, x minus 2, and x plus 2. There's my common denominator for both of my fractions. Okay, what is in the common denominator that wasn't in the original denominator? The x plus 2. So I'm going to multiply the 2x minus 1 times the factor that was not in the original denominator. Sorry, my pen just is glitching all of a sudden. So same question. What's in the common denominator that wasn't in the original denominator? This x minus 2. So we'll multiply the x plus 2. Oh, I just saw something. This and this are common, but I don't want to cancel them out because I lose my common denominator. But just be careful, don't do that. Don't cancel it. But do recognize that it is common. All right. So let's simplify. On bottom, we have an x plus 3. Whoops. We have an x plus 3. We have an x minus 2. And we have an x plus 2. Over here, sorry, just looking at the end, it does cancel. All right, I'm just going to keep going. We'll see it at the end. It'll be a good learning experience for when you have to simplify at the end. We could have simplified right now, but we'll simplify at the end. All right, so on top we have 2x squared plus 4 minus 1 is plus 3x. If you can't do that in your head, then go ahead and just multiply the whole thing out and write it all out. But I just went 4x minus 1x is 3x. Minus 2. Over here I get, we should recognize that, difference of perfect squares, right? So this becomes a minus x squared minus 4. Combine like terms, I have 2x squared minus 1x squared is x squared. I have 3x and I have 3x. Man, my pen is glitching. So I have a negative 2 minus a minus 4 is a negative 2 plus 4, which is a positive 2. All over my common denominator of x plus 3, x minus 2, and x plus 2. All right. This top factors into x plus 2 times x plus 1. And I notice I have an x plus 3, an x minus 2, and an x plus 2 on the bottom. These x plus 2's can go away. My final answer, x, what is that, x plus 1? Sorry, my pen is just not having it tonight. x plus 3, and x minus 2. All right, so let's just look back here. What I see back here, since this x plus 2 can cancel out of both of the fractions, I can do that. So I could have made this a whole bunch easier right at the very beginning. And this could have been just 2x minus 1x, which was x, negative 1 minus a minus 2, which would be plus 1. And my denominator is just x plus 3 and x minus 2. Now, let me make sure I clarify that. The only reason we can do that is it cancels out of both fractions. Okay? If it didn't cancel out of both fractions, then I would have to leave it in there as my common denominator. But it does. So like this one right here, I can cancel x minus 2, x minus 2. Well, then I lose my common denominator, so that didn't help at all. Okay, the only reason this works is because I can cancel it out of both fractions. Okay, and we get the same answer as what we had. Okay, that was a good learning, a lot of work, but a good teaching moment. All right. Hopefully you're trying these. Once you get the hang of these, if you're needing my explanation for this one, you should be trying this one now on your own. So hit pause and try it on your own if you have not already done so. Okay, this factors into x and x, 3 and 1. I need a positive 2, so the 3 is positive, the 1 is negative. Over here, a 2 comes out, and I get x minus 1. Common denominator is 2x minus 1, x plus 3, and that is in both denominators. Maybe I need to slow down. It's not liking to write. Okay. What is in my common denominator that wasn't in the original denominator? A 2. So I multiply the 3 times 2. What's in my common denominator that's not in the original denominator? X plus 3. Multiply 1 by x plus 3. Leave the x alone. Combine the 6 and the 3. On bottom I have 2, x minus 1, x plus 3. Nothing common in top and bottom. We're done. All right. That was kind of a rough 5-10 minutes. Okay. Find the 15th term. So this is stuff we just got done doing. Arithmetic or geometric? Subtracting 6 every time, right? So it's arithmetic. So my form, my sequence equation is a sub 15, which is what I'm looking for, equals first term 29 plus n minus 1 times d, which is a negative 6. And in this case, I do know. Take that back out, put in 15, grab a calculator, type that into the calculator, and you should get the answer negative 55. Let's write that in good notation. A sub 15 equals a negative 55. Question 52. Find the 14th term. So a sub 14. Next question is, what is it? I'm multiplying by 3 every time, so it's geometric. So a sub 14 equals the first term, which is 5, times r, my ratio. What am I multiplying by? 3 raised to the n, which in this case is 14, minus 1. Grab a calculator, type in 5 times 3 to the 13th power, and you get a big number. 79, 71, 61, 5. So we have 7,971,615. Arithmetic, add or subtract the same amount. Geometric, multiply or divide the same amount. If it's subtraction, you want to think addition. If it's multiplication, you want to division, you want to think multiplication or convert to multiplication. Okay. Sum of the first 25 terms. So we're doing a series formula. And what formula am I looking at? we are adding 9 every time. So it is the arithmetic series formula, which says take the number of terms, 25, times the first term, 18, plus the last term, which is a sub 25. So I need to find the 25th term. A sub 25 equals 18, doing exactly what I just did right here. Plus n minus 1, n is 25, times the difference. The difference was 9. So a sub 25 ends up being 234. When you number crunch that, when you type that into the calculator, divided by 2. Type that mess into the calculator, and you get 3,150. Does the following sequence converge? Answer, I want to look at my ratio. 12 divided by 24 is 1/2. 6 divided by 12 is 1/2. 3 divided by 6 is 1/2. Does the sequence converge? Yes. Explain why, which is not here, because r is less than 1 and technically greater than 0. Okay, if it converges, find s sub infinity. S of infinity equals the first term. 1 minus divided by, wow, 1 minus 1/2. I hope this is recording even though I'm glitching all the time. 24 divided by 1 minus 1/2. Getting a little nervous that this is not recording, and I would be not happy. Sorry, I'm talking to myself now, which is 48. It's pushing 10 o'clock at night. I need to get out of here. All right, last one, evaluate. This is a series. What kind of series? It's arithmetic. Why? Because we are adding. It's in the formula of an arithmetic sequence. So my S sub 45 is what I'm trying to figure out. I'm trying to find the sum of the first 45 terms. It's arithmetic, so I'm doing the exact same formula I did up above here, right? So this formula right here, number of terms, 45, times the first term. How do I find the first term? Plug in 1. 34 plus 4 is 38. How do I find the 45th term, right? A sub n, which is the 45th term. I take 45. I put it right here. 4 times 45 plus 34. Oh, I didn't do it right on my answer key. I'm going to have to do it on a calculator. I'm going to hit pause and do that real quick. Yeah, if you're looking at the answer key, it should be 214 here. I did n minus 1. There is no n minus 1, or in this case, there is no I minus 1. So just be careful on that. That was another good, I did it on purpose. It's a good teaching moment. Don't do like Minogue. All right, so plug in the 2, plug all that mess in. Now I got to do it again because the answer key is wrong. So 45 parentheses 38 plus 200 and I wrote the same thing that was on my answer key, but not what was on the calculator. That's a 14. 38 plus 214 equals, divided by 2 equals 5,000. Where'd my key go? 5,670. And if you're looking at the answer key, I had 5,602.5, but it's not, because this was 214, not 210. And somehow I had 39 for the first term and not 38. Wow, I really messed that problem up in the answer key. All right, that's what it should be. Okay, question number 56, last one. Evaluate. This is a geometric series, so we're doing S sub 17. Geometric series formula says take the first term, so I plug in 1. 1 minus 1 is 0. 4 to 0 power is 1 times 3. First term is 3. 1 minus r. R is 4. raised to the n power, which is 17, all over 1 minus 4. Yeah, okay. Plug that into the calculator, and you should get a large number, 1.722 times 10 raised to the 10th. It's a good thing this video is done because this computer is not doing well. All right, there you go. Sorry about the last 30 minutes. It didn't go so smoothly, but I think you get the idea. All right, hope that helps.